Alright, so obviously I have example 11, which is from section 2.7, and this is talking about how particles are moving and their acceleration, velocity, those things. So, excuse me, first we have the position function right here, and it also says that t is going to be greater than or equal to 0 because you can't have negative time. And so the first part is asking us at what time, so what value of t does the particle have a velocity of 20 meters per second. So velocity is the derivative of the position function. So first we'll take the derivative of our position function. Alright, so that is going to be our velocity function, and we're going to set that equal to 20 and solve for t. So we can set this equal to 20. And go ahead and solve this. And so we get 0, 5, and -2, and we're going to ignore this because t cannot be less than 0. So those are the times we have there, and then part B is asking us at what time is the acceleration 0. So acceleration is going to be the derivative of our velocity function. So take the derivative of the velocity function, and that's going to be 12t squared minus 24t minus 40. And we can set that equal to 0. And I'm going to solve it with the quadratic formula. Now we can do a little bit of factoring here. Let's divide everything by 4 basically. And oh, and I don't think I mentioned that's what I did up here in this part, was I divided this by 4 and then I factored. So then the quadratic formula going to look like that, and that's going to give us 3 plus or minus the square root of 39 over 3. And again, we can ignore the negative because t has to be greater than or equal to 0. So the only spot where acceleration is 0 is 3 plus square root of 39 over 3. And the second part of part B asks us, is the particle moving forward or backwards when this happens? So if we were to plug this value right here, the time that we found where the acceleration equals 0, into velocity, because if velocity is negative, then that means that the particle is moving backwards, and if velocity is positive, that means the particle is moving forwards. So if you take this and plug it in to our velocity function, then you're going to get a negative number, and so it is moving backwards. And then number 2, the true or false question, it says if the acceleration of a particle is constant, then the particle must be speeding up. So not necessarily, because acceleration can be negative. So if you have somebody, say, driving a car and they are going forward and then they start to slow down, then they would be decelerating. In other words, their acceleration would have a negative value, and they might be decelerating at a constant value of, say, negative 100 feet per second or whatever value. So that's not necessarily true, so it's going to be false.